it's a lot of fun to do things like this as a workshop. So what we mean by workshop is it's not just me doing a canned up demo. It's we're going to have Ted Lin, who's joining us today. He's a technical consultant working in our sales team at Shinydocs, doing part of the presentation, and Jed Cawthorn, the principal evangelist at Shinydocs. A lot of people in the information management, information governance space will know Jed very well. He's a well-known author and speaker. Just to show you that it's not necessarily a technical thing as well. Jed being, of course, very technical himself, but not at the level of Ted, no offense. So we want to make sure that people see that as you follow along, this is software doing the work for you. And it doesn't necessarily require a super high-tech person to be doing it. So certainly, thank you so much for joining here. There's still lots of people trickling in to this. So for those of you who have just joined, we just did some very quick introductions. We will have Ted and Jed showing, and myself talking a little bit. I am the CEO of Shinydocs Corporation. For those of you unfamiliar with Shinydocs, we have been around for almost 10 years now. And we make it our priority of understanding where people's information is, mostly documents, media, files, and records. We have, if we were to say that we're world-class experts on anything, it is definitely your file shares and that adjoining with your M365 experience with OneDrives and SharePoints as well. And we do have some cool history. We are OpenText Technology Partner of the Year 3 times in a row. Oddly enough, not necessarily working within the content management systems themselves, but trying to get all of the other data that's out there well understood and well managed. So you're not here to listen to me talk about our company. We're here to talk about preparing your data for AI. Ted, if you could just move the slide ahead one. So the hardest part of artificial intelligence, which happens to be, in my opinion, the hardest part of records management, the hardest part of information governance and other things, is making sure that you have clean, well-prepared data at all times that's based upon a complete data set. So historically, people have tried to hire data scientists to collect the data and do that. No offense to the data scientists, lovely people who are very smart. They weren't experts in records. They weren't experts in document management and these types of things. So it was very hard for them to pull together the information to even get started on a lot of AI projects. So we spent a lot of our time, rather than saying, we're going to build the next best AI, I don't think we're going to be able to compete with Microsoft and ChatGPT. I don't think we're going to be able to compete with a lot of the other AI engines out there. So we're focusing on a different aspect, and that is preparing the data to be complete, to be clean, to be used by artificial intelligence. So today we're going to spend a little bit of time on the data preparation. And of course, we're going to show you creating the AI models, using those AI models to make real business decisions, and some cool other interfaces as well. So part 1, prepare your data. Part 2, we're going to tag it up and make it ready for AI. And then part 3, we're going to test that AI on some information that was not part of our initial data set. So let's get right into it. Moving on. So the first use case that we're going to show is classifying information based upon your existing information. And then the next thing that we're going to show is extracting out particular key elements of information. Like, for example, whenever a new document comes into your email or comes across and you want to find out the legal matter number, the purchase order number, these types of things, AI can just do that for you and help you route that information. So we'll show you how that's done and show you then how we can automate some business decisions. And we got some cool chat interfaces and other things to show. So again, rather than telling, let's find the information first to prepare it for AI. So Jed, can you show us how to find our information first?
Absolutely. And if everyone hasn't picked up on the visual cues, I'm not as technical as Ted, so I'm wearing a shirt and tie because I'm the business person. So what you can see here is the same varied amount of stuff that you'll find in any business context, whether it's our file shares, whether it's an OpenText content server, whether it's Microsoft 365. We have lots of sources that we want to clean up our information. And we help you do that through presenting you with some lovely dashboards so that you can see what you have, where it is, and how much of the stuff that you have got. So in this case here, we can see some 282,000 plus files, only 52,000 of which are unique, and we'll come on to that in a minute by looking at duplicates, and a total size of 97 gig. And then if we go down beneath that, we can see, you know, we've got a lot of emails, we've got a lot of docx, and we have a lot of PDFs, as you might expect in a normal business environment. So first of all, we have a look at how much we've got, where it is. As I mentioned, though, we seem to have a lot of duplicates there. I mean, when we're talking about ingesting our stuff into AI, we don't want the machine learning to get bogged down by processing, you know, the same content multiple times because we've got duplicate files. So we can spot, find, and figure out how many duplicates we've got, and then decide what we want to do with them, archive them, remove them, delete them completely. But in this context, the one thing we don't want to do is clutter up our AI machine learning process by feeding all these duplicates in. So we get rid of them. The next example, though, kind of depends on what you want to do with your machine learning. So what this dashboard is showing is files identified as containing sensitive data, in particularly PII, personally identifiable information. So in this pie chart here, we can see we've got postcodes, we've got Canadian social insurance numbers, Visa and MasterCard numbers, and Amex too, let's not leave anybody out, and even Ontario driver's licenses. So depending on what you want to create your machine learning model for, you may want to know about this stuff because you're actually training a model to go and look for some of it, work with some of it, or the complete other end of the spectrum, you may want to not feed your model with sensitive data because that's not what you're doing, and you have concerns about privacy and feeding such sensitive data into a model, even if it's your own private model. So we show you how much you've got. You decide what you want to do with it in your context.
Awesome, Jed. Yeah, thank you. So Ted, back to our slides there. If you can move it over to slide 4. So the first thing that Shinydocs automatically does, and I hope that was kind of almost boring and maybe a little jarring, is we pointed at file shares, SharePoint, OneDrive, Teams, and we look for all that stuff automatically. Nothing of what you saw there isn't, it's just out of the box Shinydocs. We look at those systems, and we say right away, based upon the rules that we have set, here's your personally identifiable information. You do not want to include that in your models, because if the AI starts spitting out somebody else's name or their personal information, very bad. Obviously, the deduplication for a lot of our customers, they save anywhere between 30 to 60% on their migration, their storage, their backup, administration costs, because they just continuously know where all the duplication is. All that's pretty valuable, but it's all the same stuff that you need to do to prepare to find the information. One of the cool things that we did in there was get all of the text of every document into a very Google-like search index that we're going to use right now to create classifications for documents. So yeah, there's the question in there. Two questions actually. It's in Brian is taking the lead, and I'll address them right now. How does this compare to the Microsoft data loss prevention capabilities? Very similar. The trick that we find is that once you actually get everything that you want into Microsoft, you can do a lot of this stuff. I would recommend considering Purview for records management. I would consider using data loss prevention, which is kind of, it's mostly regex based and all that. We don't want to get into the technology, but it's fine. The issue that most of our customers have is when we engage with them, we find that 60, 70, 80, 90% of their content's on file share, email, and other locations. It's in Teams, it's in OneDrive, it's in some in SharePoint. What we find is that the reality is different than what we'd really like to see, and that is, let's get everything into SharePoint properly tagged so that we can use those things like the Microsoft DLP capabilities. So that's all I'm going to say about this is about wherever your data is right now, we are going to use it for AI. And if you can get it into SharePoint and properly tag it or something like that, then the DLP will do great. I'm not going to say use us instead of that, unless you are in a reality where I'm never getting those linked Excel spreadsheets into there. I'm never going to get my CAD drawings with XREFs. I'm never going to get all this other content into Microsoft, because if you can't, then you can't do the DLP. I hope that makes sense. Sorry about the side quest for others, but let's get into tagging the data for classification.
Yeah, let me take over there. Bring you guys over here. So, all right, so what I'd like to do first is I'd like to pull up kind of a Google-like search as what Jason stated here. And for this example, what I'm going to do is search for job offers within all the repositories that contain within this search engine. So as the search results come up, we can quickly start to see there are actually a bunch of job offers here. And I'm going to quickly zoom in here just to verify. And we can probably all agree that these are all job offers. So let's go ahead and tag them. And I'm going to add a tag for job offers. Brilliant. Now they're all tagged. And I do want to pull a couple more examples here, just so that we have some more data. I want to start to search for purchase orders as well. And same thing with the search. Let's just quickly take a quick glance. We can verify that these are all purchase orders. So let's go ahead and tag these as well. That was simple enough. And to be honest, I haven't had time to have lunch, so I'm a little hungry. So I want to look for recipes so that I can see what can help me to create some food a little later after this meeting here. So we can see that there are a bunch of recipes here, some very good recipes that I will surely try. And then let's go ahead and tag these as such as well too. Excellent, that was easy enough. And now let's flip back to the dashboards here. And what you'll notice is that we completely tag these and we accurately classified them based on just a simple action that I performed. And we can see within this dashboard, we have now 18 job offers here. We have 15 purchase orders and 15 recipes. And this is all shown here within the Shinydocs system here.
Thanks, Ted. So we're going to talk about what we just did there, what we just saw. And that was, and I hope everybody agrees that they could do something like this on the call, is you let Shinydocs do its magic thing. It crawls your data and it allows you to search it, just like you might search on Google. Then you use either keyword searching and all sorts of other powerful searches to find the information that you think would be great examples of things that you would like to use for AI. Different classes of documents, if you want to classify the documents. And you just click that tag button, tag it as this, tag it as that. That's all you need to do. If you can search, you can prepare data for AI. So what Ted's going to do right now is he's going to click the extract button to extract out the AI model creation. And Ted, before we switch it back over to Jed to show how we're going to use this, I want to show behind the curtains. The neat tech thing that we're actually creating that has nothing kind of really to do with Shinydocs. It's just, this is what input for AI models look like. It's literally, here's the keyword recipe, and here's a bunch of text that describes it. Here's a purchase order, here's a bunch of text that describes it. So this is the same way that you or I would memorize what it means to be a job offer. Job offers tend to have these kind of words, purchase orders tend, every one of your document types has these types of content. And this is the beauty of where AI kicks in, and this isn't Shinydocs' AI that we're going to show. We're going to show this, in this case, using OpenNLP. But this is the same input that you might use to use Microsoft's AI, to use Google's AI. This is the same input format. This is the same technique. So we're going to show it to you using one specific technique of this, but this is what the data scientists are creating. And Shinydocs completely did this without you having to learn how to do any of it. All you did was Google-like search interface, tag a document. In this case, we tagged a couple of dozen, I think 45 or something like that. And that becomes our input for our data model. So what do we do with this input for the data model? We feed it into our AI engine of choice. It could be OpenAI's. It could be like Google's. In this case, let's go over to Jed and let's have a look at it using, in this case, this thing called OpenNLP, which is part of the Apache project. So it's just what we chose for this demo.
Yeah.
Go ahead, Jed.
Yeah, I'm you know, the difference between the J and the T, Jed and Ted is technical and Jed isn't. So just to show again, this is our great big corpus of job offer Word documents of which Ted tagged, and an example that you can read as a human is one of these documents. And what we're training here is our machine learning model to be able to read and understand this kind of input. So, as Jason said, it doesn't really matter what tool we're using because this is just an exemplar. And in this case, we are going to upload a training model. And we are going to train our machine learning algorithms to look for job offers. Et voila, 'tis done. Haha, now let's give it a quick test. So if I go to the web, rather than using our corpus from the file share, which I showed you, let's go and look for job descriptions, job offers, and pick something at random to do our testing, rather than one of the documents we used as our training set. So I'm just going to grab this text. That'll do that much. And we'll copy that in and paste it here. And classify, and boom, job offer is the predicted category for this given text. Thank you, machine learning algorithm. However, that is one test. I think I'll do another one just to make the point. So we'll go find a different, oops, wrong tab. We'll go find a different job offer. And let's grab this. Oh, skills and qualifications. That seems important. Same thing, we'll go back and we'll hit the classify button and boom, again, job offer is the predicted category for the given text. So what we've done by tagging all those documents as job offer is provide some quality control metadata that helps the machine learning model understand exactly what it is it's reading and helps with the quality control that we're depicting here by doing a quick test for you. And back to you guys.
Awesome, thank you, Jed. So over to slide 8, if we could, then Ted. Yep. So just to quickly summarize what it is that Jed showed you there, and I hope you picked up on it. We used the Google-like search interface and said, hey, these are job offers, these are purchase orders, these are recipes. So somebody who's like an information management professional would just use a Google-like search interface to just, if you have 500 different document types that you're interested in, you do 500 different searches, you set those as the tags, you do the extraction of that content into that magic file that Ted showed you. You don't have to worry about what's in the file. We just look after that for you. And then you feed that into your AI algorithm of choice. And the cool one that Jed was showing was a pretty little UI that we put on top of OpenNLP. Again, you don't have to worry about what OpenNLP is. But what I want, hopefully people walk away from this meeting not going, hey, oh, Shinydocs AI is better than ChatGPT, because we don't have Shinydocs AI. Well, we do, built into how we found personally identifiable information and that kind of stuff. Forget that. But the AI models that we're here doing is we're just automating the preparation of the models, taking that file share data that has a bunch of junk in it and just making it super easy for you to sift down to the exact information that you would like to use as examples for your AI, and then do the AI training without having to do anything overly technical. So we, in literally, however, 21 minutes, we got to the point where now with a pretty good accuracy, with only 45 examples, we can now predict, is this a job offer? Is this a recipe? Is this a purchase order? Obviously, if you want to add more document types to it, you add more. If there's 2 or 3 document types that are super similar, then you want to add more examples of it. So that does a better job. And that's for you to test and to go, again, we just help with the data preparation. So that's one use case. The idea of, okay, I'm looking at something, some text, some document, whatever. What is that document? Let's talk about actually extracting out particular pieces of information. Like, for example, when I look at a contract, I want to be able to figure out who the buyer and who the seller is. I might want to find the matter number. If I'm looking at a flattened CAD drawing, I might want to find out like the dates and who the approving engineer was. These are cool things that make it easy for you to drive automated workflow within your business. So how do you get there? How do you train up a system to be able to make guesses as to what this important information is within your data? Go ahead, Ted.
Yeah, sure. So let's flip back to our search for a second. And again, I'm hungry. So the reason why I'm using this example is because it's great. It tells us and it gives us the ability to look at some entities and attributes. So what I mean is, for example, we can start to look at the entities, ingredients in this case. So we can see things such as red potatoes, starch, lime, garlic, and those attributes, we will call them techniques in this case. And we see such actions like bake, cool, mash, and sprinkle, right? So what I'm going to pull up now is this is an extraction of the values out of an ERP system or a business system. And what you'll see are the entities, right? We have ingredients, we have fruit yogurts out of it, nuts, cloves, and the attributes, right? Technique, as what we saw earlier in the document here, we have boil, bake, steam, blanch. And what we'll do is use this extracted data to then automatically tag the entities and attributes to, again, improve our model for AI usage.
So I'll give an example based upon this, and then Ted will show you kind of how the magic trick works. Is with one of our customers, they had a lot of what we'll call tower sites or job sites that they owned where they were doing work. And inside of their ERP system, they had a list of 250 or so of these job sites. So what we did is we took the names and the aliases of those job sites from a list from their ERP system and just used our Google-like search, but not manually. We have an automation for this that just magically happens. We ingest that Excel spreadsheet and it pre-calculates a search for everywhere that those job sites were named. And then and this was run by one of our innovation team, Mr. Mark Krotz. He then took all of their documents, the corpus as Jed would call it, all their documents, and then threw it at the data model that we created out of these 250 known locations. And it found another 50 locations in their documents that the ERP system didn't know that this customer owned.
Nice.
The customers knew, but the ERP system didn't have record of them. So in their documentation, they had all sorts of jobs out there that were actually active. People were paying money and they were maintaining those sites. And then it's a kind of a cool data quality thing that we could do. So the idea of doing this pre-calculation is super powerful for then being of known terms, then allows the computer to go and say, well, here's another spot where that term seems to be used. Here's another spot, and here's what the data is. So let's show that in action here. Ted, I'm going to ask you to show the intermediate thing that Shinydocs spits out. So if you can, again, I apologize to people for showing you a text file, but I think you want to see behind the curtains a little bit. So Shinydocs pre-calculates all the searches. So inside of those recipes, in this case, we find every ingredient that's known. We find every, this space, the ground beef, or we find different techniques, like we're creaming something, we are rolling something, we're preheating, we find soup, carrot. You get the idea. It just pre-tags and pre-calculates this information. So now that we have this cool model, this input for the model, we can use this against, as Jed showed before, stuff from that we've never seen before to make really accurate estimations as to where are the values that I'm looking for. In this case, ingredients and recipes. Where are these ingredients? So let's have a look at that.
Yeah, perfect. So let's pull up that same tool here. And with that model, that trained model, so I'm going to go ahead and give that a go. And as I said, I'm hungry, as you can tell. So I quickly searched a recipe that I can quickly make because I don't have time. So there's spaghetti with crunchy crusts from Rachel. So what I'm going to do is I'm going to take some blurb from here. So let's just take this and let's see what I need to help me create a dinner or lunch in this case for myself in a timely manner. And let's extract the entities from it. So quickly, what we can see, now I know the ingredients that I need just from this blurb are water, spaghetti, pasta, and the techniques I need to learn and master or boil, spread, and turn. So great, like we have this information for me to, for me to start my new cooking career, I guess you could say, for my lunch.
Cool. So let's pause there to kind of revel in the fact that this is exactly what we're trying to do. We're trying to train an engine to say, based upon the words that are being used, guess at which is the important word that I need. Like, for example, in a contract, who are the litigants, who's the buyer, who's the seller, who's the vendor, who's the customer. These types of things can be trained into this exactly the same way that Ted and Jed showed you here. Is literally I have a list of things that I know are the types of values I'm looking for. I have a list of documents that I know are the types of documents I'm going to look for them in. And then you mash that up, and that becomes something powerful and predictive for you to then be able to, the next time one of those documents comes in that you've never seen before, it's just going to do a great guess and say, okay, this is the matter number, this is the purchase order number, this is the engineering certification provider, this is like whatever that thing that you have trained on. So please don't think that for a second that Shinydocs only does recipes, purchase orders, and job offers. This generally applies to anything, and I hope you agree it's pretty easy to prepare this type of information. Anybody can prepare an Excel spreadsheet with a list of known terms. Anybody can prepare or do a Google search and search for terms. So it's Ted, if we could go back to let's hit slide 10. And we're going to go ahead just one. Cool. So here's how this all fits together. Obviously, ChatGPT and the new large language models are the things that are getting us all really thinking about this. And you're wondering, okay, how do these easy use cases that I'm talking about, like classifying information, like knowing, is it a purchase order? Is it this? Of course, we can do the same thing with image recognition. Is it a dog, a cat, or a lawnmower? Like, it's like there's all sorts of different ways that you can train your information. How does that plus entity extraction, the thing like, is this a purchase order number? Is this somebody's name? Is this an ingredient? How does that all add up to something like a large language model? Well, all a large language model is in this case, it's ChatGPT, is something like 100 or 170 billion data points that have all been pre-calculated. So it knows a bunch of nouns. It knows what it means to be a thing. It knows what it means to be a person, a place. And then it knows how, based upon previous examples, it knows how to phrase responses to different questions. So you can, for sure, upload your information into an open AI, into a ChatGPT, and then include your stuff as part of a search response. That's cool. There might be some ethical issues associated with that. There might be some legal issues that might stop you from doing that. So I'm going to show you we're going to show you a fun example of a chatbot that instead of 170 billion different data points, this one only really has one. It has ingredients, but it's exactly the same idea as ChatGPT, just kind of a fun little example. So in this case here, and then I'll pass it over to Ted, We've got the chatbot that says, hand me your recipe and I'll break it down by ingredients and techniques. So Ted, go ahead.
Yeah, sure. I'm just going to type quickly here. Tell me what I have from this list. And I'm going to paste that same recipe in there. And voila. It tells me, yes, chef, I found these ingredients: spaghetti, pasta, boiling water, and I found these techniques, right? I need to turn, boil, and spread.
So in this case, we used a very small large language model. It knows how to answer the question about ingredients. That's it. It only knows one thing. We trained it on one thing, but you could add, in this case, like what's important to your business. Do you want to be able to do have help desk support, be able to ask questions? Do you want to get to the point where you can say, hey computer, I'm standing in front of pump number 3, can you give me all of the design drawings and the as-builts? That's the type of thing that it already works with the existing AI that's available through Google, available through open source, available through Microsoft. It's totally awesome. And all we're doing, all Shinydocs wants to do is you to walk away and go, hey, preparing my data for those use cases is a whole lot easier because I don't have to worry about finding the right text. I don't have to worry about filtering it. I can update my models whenever I want just by going in and doing what Ted and Jed did and just tag some extra information. So I hope that you found that to be pretty interesting. So from this, you can automate your decision making. Again, we're just talking about preparing your data. We want to make it super cheap. We want to make it super easy for you to just be able to do this. So we don't have our own workflow engine. It's not a thing. We just have the ability through APIs and other techniques to be able to ask questions of the data and then get back an accurate prediction based upon that data. So I suggest that you worry about automating your decision-making in your existing systems. If Salesforce is where you drive your business, or Maximo or SAP, do that. Drive your business from those particular workflow engines. Or if Power Automate is where you want to build your workflows, do that. Again, Shinydocs has an opinion on it. We even have people who can help you with that, but I don't want to build a competitive workflow product. That would be silly. We just want to be the experts that you perceive as at being able to prepare the data.
So, hey, Jason, there is a catchphrase we haven't used yet. Garbage in, garbage out.
Yeah, the old GIGO. So that's one of the things. Like, how many? It's no show of hands. You don't need to show of hands. But how many people have tried to do an AI project before, where the data scientists and others say, your data's not ready, or your data's garbage, or whatever. I can't do this for you. Well, of course, your data's not garbage. It's just fulsome. Your data's everywhere. It's in your file shares. It's on SharePoint. It's in maybe OpenText and other locations. You need a good way of collecting it, making sure it's clean, and then creating your models from that. So I like that you draw attention to that garbage in, garbage out. Thank you, Jed. Cool. All right. So I do want to, before we move on, I want to talk about what I'll call something that I've heard a lot about, and that's the ethical issues associated with AI. And I've heard some very good ethical issues associated with AI in the context of, let's say you have fully autonomous drones, you want to make sure that they're safe, whatever, making good decisions. That's kind of above my pay grade. I'm just talking about making sure documents and data is clean and useful for your business. So those are specific ethical concerns. I want to hit two very specific ethical concerns that I hope people can relate to. Ethical concern number one, and this is something that Microsoft and ChatGPT are going to have to wrestle with over the next little bit. It'll be proven in a court of law. I'm not a lawyer. But if they have used public data from the web to generate models that then generate new information for somebody else, that actually violates an entire area of the Federal Trade Commission's called disgorgement. Meaning, if you steal somebody's data, repackage it, and make something else out of it, you owe royalties, you owe something to the original copyright holders. How do you resolve that within your organization? You do it by doing this Shinydocs thing, knowing where exactly the data came from. So that model that we showed you, the input, you can records manage that and say, this is exactly why we made the decision with this algorithm. This is where the data came from at this point. So you can avoid all of that FTC concern of disgorgement, the idea that you don't know where your data came from. Well, with Shinydocs, you know exactly where it came from. This is the search result. This is where we tagged it. This was the intermediate file that we used. This is the decision that was made from the training. So you hit all of those pieces. So that is intensely a critical one. And then of course, there's also other ethical issues associated with the privacy of data. It's like, I want to make sure that if my words, Jason Cassidy, blah, 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 is in a document, I want to make sure that that doesn't get accidentally spit out by the AI engine somewhere else. So again, how do you do that? You use something like Shinydocs to clean up this data. So I hope that you find that interesting. All right. I hope that you found this rather generic. I hope that you learned a little bit about the inputs and outputs for that. I hope you agree that Shinydocs makes it easier. So I'm going to take the last couple of minutes to make a pitch, and I'll watch the number of users rapidly drop. So if you wanted to do everything that we showed you today, how does that work? Well, with us, it is, we assume that you'd start with a small project. So you can do everything that you saw here today, and we'll coach you on how to do it for $10,000 for your 120-day project. We hope you find so much value in continuously identifying privacy issues, continuously identifying redundant, obsolete, duplicate information, connecting to so many systems that you just want to keep renewing that forever. That is exactly our pitch associated with that. If you don't want to do any of the work, but you want the same outcomes, then we want to sell you a Shinydocs Enterprise. It's volume based, meaning we will help you work on what your outcome needs to be. We will assign the staff working with your staff, and we'll quote it and just get the outcome that it needs to be. So if you're confident, if you want to give this a try and do the things that Jed and Ted showed you on the webinar today, $10,000 USD per 120 days, and just use it as long as you need to. And if you'd like Shinydocs to lean in with you, which if you look at some of the reference customers that are on our website, quite often we end up rolling into an enterprise like that, then we're happy to take on the burden of these outcomes for you and show you what you need to do and be very competitive as we do it. So thanks so much for spending the time with us today. I hope that you found it really useful. And if you would like to find out more about this, please go to shinydocs.com. Right at the top of the page, there's book a meeting, and it will obviously we'll get in touch with you right away and think about the types of use cases that you might have for this type of technology. So if there's any, yep.
Yeah, I was going to say, I just want to interrupt before we let everybody go or get actually into answering questions, to give it a non-techie summary, because anybody who's ever seen me speak or read any of my stuff knows that I'm a bit of a metadata nerd. You can never have too much metadata. In this case, metadata is helping you organize your content for ingestion into AI. We did some very simple tagging with one category, job offer, or ingredients and techniques, or purchase orders. You could be tagging with tens to hundreds of fields, because we'll help you automate it. And that is where you get to prevent the garbage in, garbage out. You're helping your machine learning models understand the content you're feeding to it. And to Jason's point, you know, the modern generative stuff, GPT stands for generative pre-trained transformer. Yes, it's pre-trained on a large language model, but still, tagging your stuff with extra metadata helps that AI set of algorithms, for lack of a better term, to understand what you're giving it. So to prevent garbage in, garbage out, tag everything with a ton of metadata by using Shinydocs, of course.